All right, time to move on to equivalent fractions with push and lasso method. That method we do in class with our little dance. Push and lasso. Push and lasso. So here's what we're going to do. We're going to look at this first fraction model, and we are going to figure out what the regular fraction is. And the regular fraction has a denominator of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, of 12. And the numerator of 4. So there's our fraction. Now, sometimes you are given a fraction model to look at that looks like that one that we just worked on. And you're also asked what an equivalent fraction is of it, and you're shown different drawings. Well, that can be a little tough when your fraction is all spread out like this, because you just got it all figured out, and then somebody comes and does this to you. Well, we can fix this with push and lasso. So we're going to use our next rectangle to do a demonstration of the push and lasso. So what we have is this guy to us is in the wrong place. He needs to be pushed over here. This one needs to be pushed over here, and this one needs to be pushed over here. Now, I could have pushed them all to the right, but I chose to do them all to the left. So this guy stays the same. He was pushed over, he was pushed over, he was pushed over. So literally you would draw this on your paper. Or you could kind of cross off the shaded portions on your paper and push the pieces over by shading in other portions. Okay, so now I'm looking, I obviously have the same number of parts shaded, so that was 4. And my total parts are the same, 12. My fraction model did not change, like the fraction itself did not change. But now I'm going to try to find an equivalent fraction to it. So one way I could find an equivalent fraction now is that everything has been pushed is to go ahead and lasso. So what I have here, 4 12s, that was counting by ones. Now I can see if I can count by twos. Can I count by twos and group? Yes, I can count by twos and group because both 4 and 12 are factors, have 2 as a factor. They are both multiples of 2. So let's go ahead and choose another color here. I'm going to choose, let's choose bright pink. And we will circle our groups of 2. So I have one group of 2, 2 groups of 2, 3. Now, by groups of 2, I'm saying boxes. Okay, and once they're circled, I no longer think of them as separate boxes. I think of them as groups. So that said, how many groups did I circle? 6. How many groups are shaded? Now it is not 4. There are 4 squares shaded, but now my things are in groups. So I have to think groups. And so how many groups are shaded? Perfect. 2 are shaded. All right, so I counted by ones. That was my 4 12s. Counting by twos, putting 2 to a group, I got 2 6. Can I put 3 to a group? Well, my rule in lassoing is I can't put more than one type in one group. In other words, I can't put a group of 3 red ones together and then a group with 2 green and 1 red. That does not work. So 3 will not work. Is there another number that would work? Okay, 4 would work because 4 is a multiple of 4. 12 is a multiple of 4. Both of these numbers here can be divided by 4. So yes, 4 would work. So I'm going to circle groups of 4. 1 group of 4, 2 groups of 4, 3 groups of 4. Okay, I'm no longer looking at the other pink group, and I'm no longer looking at each red box as an individual box. So I've done 3 groups. Counting by 4s, I was able to make 3 groups, and one of the groups is shaded. So 4 12s, 2 6, and 1/3 are all equivalent fractions for this fraction model.